Today, I'm going to share you a journey of AWS and the landscape we see. I'm going to share with you the honeypots that we've created to trap these attackers. I'm going to share with you the insights that we've developed and we're trying to bring to our platform, but also share with you the largest attack we've seen on our platform, which is HTTP2. I'm Christopher Jen. I'm from AWS, and I'm go-to-market for our perimeter security in EMEA. What that means is the products that in my portfolio is WAF, is Shield, that's for DDoS protection, network firewall, all these things that we provide to our customers to protect against inbound attack. What I'm going to share with you is a team we created internally that their sole purpose is to protect our customers and our network. So their sole purpose is to protect. We created this team of software developers and security engineers. So this team, all that they do is trying to make it more expensive, try to make it that attackers think twice about coming to AWS to build and attack their other customers. So we did this very differently when we created this team because we want to spin it out, and it's all about automation. How can we automate everything we do within AWS? So one of the things you might have read in A16Z is software is going to eat the world. That's an old manifesto. And I think one of the underlying talks I want you to take away is we want you to automate as much as you can. So this team, like every other team in AWS, has a North Star. First of all, we take the petabytes of data that we see on a daily basis, that we see in many of the interconnecting networks that we have, and we take that data, which is anonymized. This is the same data that we use to build you, and we build it into our system to gain insight. This insight is shared across other AWS teams and other customers. And what we want to do is, can we now improve our defenses? But a key difference that this team is investing in is in our disruption technology. So like my previous colleague over here mentioned that DDoS isn't going away. So if we, as AWS, as one of the cloud vendors out there, can disrupt the attackers out there, we can help all of us live in a much safer place. So I will share later throughout the presentation the disruption technology that we've built and are investing in. So this is our AWS platform. There's lots of numbers on here. Where our customers, when they build on our platform, one of the things that you get is resiliency. So when you build, you're closer to your customers, you build a platform, an application that can scale. But what this gives AWS is a unique insight into the internet traffic. It gives us the types of customers on our platform are small, medium, startup businesses to the largest enterprise, to public sector, to all these different industries. So we can take that insight on the security side and build security tooling custom to different areas. But also what we want to do is bring security to the masses. What I want to draw your attention is the stat on the top right here. We protect thousands of DDoS on a daily basis. And this is all done automated. There's no human intervention. There's not a SOC that is running this. This is all done through software. And it's through that initial data set that our threat research team builds a lot of their insight from. So this is data from our systems. DDoS isn't going away. I think I've started this 10 years ago. I was hoping, right? We didn't talk about security in the way we talk about today. I think it's not surprising you hear an infrastructure attack in the news. It's sort of become not expected, but it's, either be an oil infrastructure in the east of West Coast, a German airport, group of airports taken down. it just seems every day. It is growing, and this is the latest data from our platform. We still see layer 3 and layer 4 attacks, but it's not, our system automatically protects that. We already see the innovation and the growth is at layer 7. So when customers call in to our support team and they're under attack, and we actually drill in, many times we're seeing this is at layer 7. They may be having a bot running on their network. They may be having a login prompt and somebody's brute forcing attack. It may be API security. Much of the attackers are moving up the stack, right? And they're doing that because it's an easy, well, they're innovating. We're seeing 50, 56%, 47% year over year growth at layer 7. So we're investing in this area in our solution and our research. So layer 7 attack, I think this is the largest attack we saw on our platform. Most of you probably have already heard about this, but this is the HTTP2 rapid reset event. Next few minutes, I'm going to talk about how we saw it, what defenses we built in, and how we've evolved our capability. So many cloud vendors like us, we've released information. Late into August, our CloudFront team, which is our CDN, one of the edgemost services on our platform, they started seeing anomalies on the resource utilization of our CDN. And they quickly determined that it was this HTTP2 vulnerability, reset vulnerability. Over the next few days, we were monitoring our network. We saw this attack over a dozen times against all ranges of customers, including financial services customers on our platform. It grew to a point in September where it was 4 times larger than any other previous recorded DDoS event on our platform. So if you come to any DDoS event, you'll always hear an innovation. And this is just one example of that happening. Now, what is HTTP2? It's an evolution of the protocol. It got ratified in 2015. It's trying to allow for faster throughput, more performance on HTTP2. And invariably, the attackers were able to do that. So what happened here is there's a multiplexing capability. And what it allowed the attackers to do is send multiple requests, reset requests within succession in the protocol. And as a result, the server, your application server, still has to process that, but they're just processing resets again and again and overloading the server and not be able to process a real request coming in. So what we did and what kind of patch we put in is we looked into the packet and we said, if we see more than X percentage of resets happening, we're going to then block that traffic. And this is an example of when you go to a cloud DDoS service, what we can do, we can put a hot patch. When we put this capability, it is not something wrong with HTTP2. The protocol is designed that level in that way. It's just the way that somebody was using it. So we put that patch into our capability. If you didn't have a cloud DDoS vendor, you would have to maybe patch your server itself, right? And think about how many servers you would have to patch. So one example of having a cloud DDoS service, or what you can do on the cloud. Now, layer 7, the innovation that we're seeing, our threat research team started looking at where these attacks were coming from and how they were being done. What our research looked at is we're seeing much of the network or much of the capability coming from these proxy networks. 88% of the attacks on layer 7 on our platform are using this type of network. So what are these networks? Proxies are a way to allow you to browse the internet anonymously, right? You have universities have proxies. I had to use it when I went to university, go through it to browse the internet. It can be used by legitimate users and attackers themselves. There's thousands of these proxies online. And what attackers have done is built software, proxy drivers, which are the more beefier machines, created a list of these open proxies. Maybe it's 20,000 open proxies. And what they do is they launch attacks through these proxies at you. So it looked like legitimate traffic. So it's really hard to determine because you don't want to block legitimate traffic. And what they're doing is using this network because the source IP is hidden. So this is one area we've directed our lens at, is that can we look at this network and can we take some of these down? But also, can we help build more of our defenses? Got my exercise in for this morning. So the first hypothesis we thought is these attackers are going to be reusing the same network. And we started monitoring the attacks and we built a known offenders list. I think the uniqueness of this is the scale we can see on the internet. Of September 16th, our known offenders list using this proxy network is 30,000 unique IPs. We update this every 5 minutes on our platform. And there's a lot of rigor that gets in when we add new proxies on this. And this is now given a layer of defense that we've now put into other products within our portfolio. So now we have this known offenders list. We have 30,000 IPs that we see attacks coming from on a regular basis. CloudFront, like I said, is our CDN, one of our edgemost services. So these are 600 different POPs or servers around the world. What we now have put in is this known offenders list is rate limited at a certain level on all these POPs around the world. What that means is if an attacker is using this network, we're going to absorb and drop that traffic even before you hit your own service. And you don't have to do anything on our platform. Now, Amazon.com and the console for AWS are also incorporate this. So I think a differentiator is we're eating our own dog food. If this known offenders list isn't working, we're blocking business from coming to one of the world's largest e-commerce platforms. What we've had to do is build a lot of mechanisms and processes, which AWS loves doing, to this list. So when new IPs get added, there's a process that goes in. We also have made this list available to AWS customers. So within AWS WAF, it is free. There's a managed role called a DDoS list, and you can use the same list that Amazon.com uses to augment their security in our WAF capability. Now, we haven't stopped there. This is our flagship DDoS service called AWS Shield. And what I said is innovation is happening at layer 7. When we first built this capability, it only had layer 3, layer 4 protection in DDoS. And we've had to evolve it to put some capabilities around layer 7 because we're seeing more attacks on that level. So at the bottom piece is over a year ago, we launched an anomaly detection capability. What that does is we baseline your traffic coming in. We then, when under attack situations, we take a certain level of signals, and then we build a layer 7 signature. We will then verify that it doesn't block legitimate traffic, and then we'll apply it to your WAF rules. We try to automatically create a signature for you during an attack. That takes time. It takes up to 3 minutes, potentially, at the worst case, to generate this, and we're improving this capability. So as of this year, we take this known offenders list, and we've augmented the capability. So if you're under attack, we'll automatically apply this known offenders list, and we'll start mitigating the attack while the signature has time to create a more customized signature for your attack. So my colleague also mentioned educational. I don't know why we all love talking about educational customers, but this is an example of it working in the live. So the orange is the normal traffic, and the first spike is the orange is the normal, the orange is the normal traffic. The blue is the attack, and the green is our mitigation. So there's two attacks that are happening. What you see in the first bit is our layer 7 auto mitigation kicking in, not blocking all of the attack, but blocking most of it. And at 5, the next wave comes in, and our signatures kicking in as well. So it gives us time. What I also want to show you is they're actually short. You were seeing less than a few minutes, 5 minutes. These short-lived attacks are becoming more and more. And like what my colleague said, we're seeing it as those script kiddies, they may be launching a attack as a service, but they don't have much money, right? They're not going to be able to launch it for hours. If there are hours, then maybe a nation state attacker. So this capability we've augmented. What I would have to, want to emphasize is this is not where we think it's going to end. We're building more capabilities. This is just the evolution. Now, at the beginning of my talk, I talked about disruption. And this is one of the key capabilities we are starting to talk about to the public. We had an interview with the Wall Street Journal where we, as one of the cloud providers, talked about this capability openly. And what I'm going to show you in the next few slides is just one part of this capability in the disruption mechanism we are building. So we call this the MadPot network. This is our honeypot network. It's actually part of our MadPot universe. I don't know who comes up with these names. We're very creative people. Well, when I was talking about this proxy network, we wanted to create a man-in-the-middle capability. And when we did this at scale. Everything AWS does is at scale. So the team that's created it created EC2 instances, opened up the ports, and we're trying to track attackers. We've done this. We've automated it from MongoDB servers, RDP servers, Murtec routers, a range of devices that attackers might be attacking, and we're attracting them. We're joining the network. We're opening up our proxy. We're then downloading the URLs, the payloads, and now understanding where these proxy drivers are coming from. We have also then built a novel full end-to-end detonation chamber and a proxy capability. And this is all done without a human interaction. We're spinning these up all over the world. We launched a cloud zone in Israel earlier this year. We put MadPot there as well. So we now have a lens of that, every new cloud zone that gets launched. What we do within this capability is we then start mapping the genealogy of these attacks. So when they come in, we're trying to see, is it Mirai? Is it FBot? What type of attack is it? And with that information, we're starting to build a flywheel effect within AWS and Amazon. So we start null routing all traffic. So what that means is our proxies are not, if any AWS customer is communicating with a proxy driver, we null route that traffic automatically. They're not contributing to these attacks. Our trust and safety team will let them know we're seeing customers participating. They'll reach out to the customer. Many of these proxy drivers are also part of fraud network. Amazon has a quite extensive fraud capability. We are now feeding this data into the fraud team as well. There's many other products within AWS that are around malware. So we're sharing the payload with those teams so then they can improve their services. So this is part of what we're doing, and we're seeing much success. And we're not stopping there. We're now reaching out to where these proxy drivers are being hosted. We're tracking over 100 ISPs on the internet, and we're working externally with them. And when we first started, we used to send these emails manually, letting them know this is the vulnerability we're seeing, sending them all the IOCs about that, and then asking them to take it down. We have now done this at scale. We're automating this. We're working with a third party, and we're taking down these proxy driver networks. If we take them down, we're reducing the number of DDoS happening. We're reducing the DDoS as a service capability out there. So are we making an impact? This is Telegram, and this is one of the channels that a lot of these attackers hang out. Our researchers are there as well, and we had to bleep some of the information. But essentially, this is them saying that if you try to attack AWS, and we will be tracking you, and we'll go out and take you down. We'll take down your service. We are starting to see, with this type of work, the null routing, this MadPod, less attacks happening on our platform because they're going to think twice about coming to us. So, in summary, DDoS attacks aren't going away. We're seeing more in layer 7. We're investing in a team that does disruption and builds insight. We have this known offenders list that we're building into all different parts of the service and offering for free in our WAF. And this MadPod capability is just the beginning of our investment in disruption capability. Now, the last link I have, we wrote a white paper on DDoS resiliency. It's pretty generic by our essays. We updated in August. I wanted to share it with you because I was just on I'm on all of these customer calls where they think they have right protection, but cloud architecture is complicated. You have on-premise, you have cloud, and attackers just test. And you may not have realized where maybe you've set up incorrectly, didn't set the right. They're very smart. And so we wrote this DDoS resiliency to kind of go through all the different areas you should think about. Thank you very much for inviting us, and I'll be out there for any questions.